In this video, I'm going to try to answer the question that has plagued organic chemistry students forever, and that is when faced with some substrate for a SN1 E1 E2 or SN2 reaction, how do you determine which of these is going to happen? And I understand how frustrating that is, and I know that this is how many of you are feeling right about now about all this. And the purpose of this video is, and this is perhaps a lofty goal, but is to make you feel like this once you are done or when you are working problems. So, first thing is, don't panic. That is essential. Do not panic. Break the problem down and look at all the pieces, and I'm going to go through that right now. So the first thing that you should do when approaching a problem like this is to, as I mentioned in at least one of the classes yesterday, is to RTDQ, which stands for read the darn question. So read the question. Why? Because sometimes in the question it might say something like, in the SN2 reaction below. And that tells you that, hey, I'm dealing with an SN2 reaction. I'm not saying that's always going to be in the question, but reading the question goes a long way sometimes. Okay, once you've read the question, one of the things you want to do is you want to identify what the substrate of the reaction is. And that, for the most part, has been some kind of alkyl halide, where X is bromine, chlorine, or iodide. But we've also seen water and alcohols act as leaving groups in these kinds of reactions. Then you want to identify what is acting as the nucleophile in the reaction. This is also probably a good time to try to figure out if it's a weak or strong base, because that can play a role as well. Now, time to ask yourself, is it SN1, SN2, E2, or E1? Okay, well, let's do the easiest one first. If you figure out that it's a methyl group, the substrate is a methyl group with something like methyl bromide, well, there's only one thing it can do. You need to have at least 2 carbons in the molecule for it to do any kind of elimination reaction, so you know it's not going to do an elimination reaction. A methyl carbocation is very, very unstable, so you know it's not going to do SN1, therefore it can only do SN2. If the substrate is primary, then it is very difficult for it to form a carbocation, so it's not going to do an SN1 reaction, and it's not going to do an E1 reaction. Most likely, most of the time, a primary is going to do an SN2 type reaction. So that's probably the easiest thing to go. Occasionally you can get an E2, and I'll talk about that. If your substrate is tertiary, that means it's very sterically hindered, and one of the things that we can cross off the list immediately is SN2. It's never going to do an SN2. So we know that's not going to happen. So now we need to think about is, can it do SN1 or E1? Well, or is it going to do E2? Well, one of the things you want to look at is there a strong base? Is the nucleophile actually a really strong base? And common strong bases that we've seen are things like sodium methoxide, shown here, and recall that sodium methoxide is the conjugate base of methanol, which has a pKa of 16, so that means that this is a pretty strong base. So you want to figure out if it's a strong base or not. If it's a strong base, then it's probably going to do E2. And the reason for that is a strong base doesn't allow the formation of a carbocation, which is what you need for an SN1 or an E1 reaction. So strong base, that's going to favor E2. If there's no strong base present, and you'll often see this in something like you'll see the reaction run in, remember, polyprotic solvent, so something like an alcohol, like methanol or water, that's going to do SN1 or E1, and that can give you as we've discussed, a mixture of compounds. So how do you know which way it's going to go? Well, we discussed in class that if you increase the temperature, that means that's going to favor elimination, and that's true whether it's E1 or E2. Increasing the temperature is going to favor elimination. And the reason for that is, recall that I said that the entropy, because an elimination reaction produces more products, the entropy of that reaction is going to be increased. And so as you increase the temperature, you increase this whole factor, which gives you a larger, more negative delta G, which favors the which means an elimination reaction is more favored. So increase in temperature. So if you see, something like a little delta underneath the reaction arrow, that usually indicates heat. Or if you see, 100 degrees C or some kind of, indication of temperature, that is a tell that the reaction is likely going to undergo some kind of elimination. So if there's no strong base, it's going to be an E1. If there is a strong base, it would be an E2. All right, now if it's secondary, if it's a secondary substrate, then it can do any of these things. So we need to look at things more carefully. Okay, so if you have a secondary substrate, one of the things you want to do is you want to look at the solvent. Firstly, recall, if it's a polar protic solvent, is going to favor the formation of carbocations by stabilizing them. So that's going to tell you that it could be SN1 or E1, and once again favoring having the increased temperature is going to favor elimination reaction. You also want to look at the nucleophile. You want to have in this case you want to have no strong base, also to favor the formation of a carbocation. And a polar aprotic solvent, recall that is going to that does not favor a carbocation, so that is going to favor either an SN2 or an E2 reaction. And once again, if you have elevated temperature, that is favoring an elimination reaction. I hinted at it above, but then also you want to look at the nucleophile. If your nucleophile is a strong base, and especially if you've got a polar aprotic solvent, then that is going to favor SN2 or E2. If your nucleophile is a weak base, especially if it's in a polar protic solvent, then that's going to tend to favor E1 and SN1 reactions. And once again, to determine if it's going to be an elimination, you can look at the temp. Okay. So that was a lot, I know. I am going to do a question. This is an additional question 8 from class activity 10B. I'm going to do a separate video on that because that asks you to identify what's going on in the reactions, and so I'll just do that as some example problems to go along with this. I hope that was helpful. Please let me know if you have any questions. You can ask them in the comments or you can ask them in the discussion for the class.